Everyone, I am going to explain you about how to plot a pole zero configuration for a given network diagram. To find out that poles are zero, first of all we have to find out the one transfer function. The transfer function may be impedance or admittance or a transfer value. Okay, so to find out that transfer function, first of all we have to transform this network. Like this is in time domain, this will be in frequency domain. So when you are going to transform these values, so we are going to replace that value resistor with resistor only, inductor with equivalent inductive reactance value, and the capacitance is equivalent capacitor reactance value. That value is nothing but L is equal to S into L and C is equal to 1 by S into C. As we are seeing here, the inductor value is 1 Henry, the capacitor value is 1 farad, and the resistor values are all 1 ohms only. So R is nothing but simply all 1 ohms. L value become S into L, nothing but S into 1. Here C is equal to 1 by S into C. This will become 1 by S. So this is a transformer network. Okay, so from this transformer network, first of all we have to find out the transform function. Okay, to find out the transform function, here we have the multiple methods. So here I am applying a nodal analysis. So for that purpose, here I am taking the nodes, like 3 nodes A comma B comma C, and here I am applying a nodal analysis at node C, so which is equal to V1 of S minus VC of S with this 1 ohm value, as well as V2 of S minus VC of S with this 1 ohm value, which is equal to VC of S by 1 by S. So here this is the nodal analysis at node C. So upon simplifying this, we are getting V1 of S plus V2 of S minus into here minus VC minus VC. This will become minus 2 into VC of S, which is equal to S into VC of S. So here I am writing VC of S in terms of V1 of S plus V2 of S, which is equal to VC of S is equal to V1 of S plus V2 of S by S plus 2. Just make it as equation 1. Similarly, apply the nodal analysis at node B. So at node B, which is equal to, this is a node B, which is equal to V2 of S minus V1 of S by S value plus V2 of S minus VC of S by 1 value plus V2 of S by 1 value. Okay, this is the nodal analysis at node B. Okay, so this is V2 of S minus V1 of S by S plus here V2 of S plus V2 of S, nothing but 2 into V2 of S minus VC of S. Here I am taking the LCM, so the total LCM is equal to S value. So therefore V2 of S minus V1 of S plus S into 2 into V2 of S minus VC of S, which is equal to 0. Upon simplifying this, we are getting VC of S is equal to V2 of S into 1 plus 2S by S minus V1 of S into 1 by S. Okay, so here we have to substitute the VC of S from the equation, which is equal to V1 of S plus V2 of S by S plus 2. So this is equivalent value. Okay, here cross multiplying these two terms. So here we are getting, upon cross multiplying this entire, here we are getting V2 of S, V1 of S into 2 into S plus 1, which is equal to V2 of S into 2 into S square plus 2S plus 1. So here we want the one transfer function, which is V2 of S by V1 of S, which is equal to S plus 1 by this S square plus 2S plus 1. So here we am writing this is S plus 1 whole square. So therefore S plus 1 by S plus 1 whole square, one term will get cancelled. Here we are getting minus S plus 1. So therefore the transfer function V2 of S by V1 of S, which is equal to 1 by S plus 1. Here the numerator term and the denominator term. Here we are getting the numerator as 1. So therefore there is no zeros, and the denominator is S is equal to minus 1. Upon substituting S is equal to minus 1, so we are getting this value as infinite. This transfer function as infinite. The root which make the transfer function as infinite, those are called as poles. So therefore zeros are no zeros, poles are S is equal to minus 1. Here I am plotting these poles and zeros in this S plane. So this S plane is S is equal to sigma plus j omega. J omega is the imaginary part, sigma is the real part. This is the real one, imaginary one. So here we are getting S is equal to minus 1. Here plot this. So this is the poles and zeros plot of a given network. Thank you.